Okay. Hello, I'm presenting Urumi, a Kubernetes native platform that provisions fully configured WooCommerce stores on demand. Each store runs in a completely isolated environment with automatic setup, sample products, and payment gateways configured in under 3 minutes. Let me show you how it works. Speaking of the system architecture, so this is a three-layer architecture that has a front-end React dashboard for creating and managing stores, back-end Node.js API with four core services that contains the provisioner or manager, which orchestrates the Helm deployments, the queue manager, which limits concurrent operations to three, the quota manager, which enforces 10 stores per user, and the audit logger, which tracks all the operations. Okay. Why we use Kubernetes? So each store gets its own namespace with WordPress, MariaDB, persistent storage, network policies for isolation, and resource quotas, preventing resource exhaustion. Okay. So looking at the demo, so currently this has been hosted locally on my PC. So let's just get started. So when I click on this create store button, I can type in any name. So let's just put in random store one. Okay. And then I just click on confirm and launch. So the provision requested gets accepted, and then we can start streaming whatever is taking place over here. Okay, so the provisioning generally takes around 30 to 40 seconds. It doesn't take a long time. Let's just wait for that. So let me just look into let me just go through whatever is happening right now. So what happens is when I click on the create store button, the backend validates and enqueues the request. It creates a Kubernetes namespace. The Helm deploys the WordPress plus MariaDB ingress, and the post start lifecycle hooks runs setup script. So it installs WooCommerce and creates 5 products automatically and configures payment gateways as well. So I have created a dummy payment gateway for the same, and then the status updates from provisioning to ready, which will happen in a bit. Okay, yeah. So now, as you can see that the user and the password have already been put in the values.yml file. So if I just click on the admin button, I'll be able to log into the website. So now let me just quickly log in. So this is my admin panel, user and PASSWORD. Okay, login. So now it takes a bit of a time. So this is completely a WordPress setup, and that I'm able to log into the WooCommerce admin page. Oh, okay, so yeah, so with this we can start setting up the store. So I'll just skip the guided setup for now, and I'll just put in my region as India. Okay, great. India, Maharashtra. Okay, go to my store. Okay, so yeah, so this sets up the admin panel for my store, and then I can look into this complete setup. So this is the home page. It's loading up right now, so I can customize it. This shows the orders as well, whatever is happening. So let's just say I go to my store and visit it as a customer. It shows me the standard items that have been added to the YML files, and then I can just add it to the cart. I can click on the view cart and proceed to checkout. Okay, and then let's just put in my values. Okay, and then this is the dummy payment gateway that I have made. So I can just directly click on the place order, and then again when I reload this, it shows that I have put in an order on this. Okay, and then I can just put it as processed, and yeah, it starts processing the order as well. So this is what has been implemented on the store side. Now again, one of the requirement was that when we deprovision this store, everything needs to be deleted. So when I click on this delete deployment button, the Helm starts uninstalling the deployment. The Helm uninstall removes the deployment. It explicitly deletes the PVCs. That is critical since they don't auto delete. Then we wait for the termination as well, and then the namespace is also deleted, and if stuck, we also apply force delete for the same. So as you can see, the store has been completely deleted. And then I have provided with a few commands as well, where we can actually test out in the backend that if the store actually gets deleted or not. Let me just check. So yeah, so in this, as you can see, the random store, it was generated, and then we were also able to delete it from here. Okay. See. Speaking of isolation and reliability, so what we have done is, for the isolation mechanism, we have put in a namespace per store with network policy that denies everything by default. So only the WordPress can talk to MariaDB, and lateral movement is prevented. So the resource quota limits for each store is up to 2 CPUs, that is 2 GB RAMs and 3 PVCs, and the secrets per namespace is mounted as files. As for the reliability is concerned, it is idempotent provisioning, safe to retry failures, liveness and readiness probes, auto restart, unhealthy pods, multi-stage cleanup with force delete. As for the security, the secrets are generated by Helm and stored as Kubernetes secrets, never committed to Git. Production uses external secret managers and RBAC as well. The backend needs service accounts with minimal permissions. Just the namespace, pod, deployment management, container hardening, and the Bitnami images run as non-root user. And as for the horizontal scaling is concerned, the backend API is completely stateless and runs multiple replicas with HPA. The dashboard is also contains static assets and is CDN ready. The ingress traffic can handle a scale for traffic. As for the stateful constraints, MariaDB doesn't scale horizontally, a single primary per store. So the provisioning is limited to 3 concurrent via queue and prevents cluster overload. Okay, so that's it for my video.